Okay, in this video, I'm going to talk to you about the quotient rule. Now, the word quotient is the answer to a division problem. So each problem that you see on this video is when we have two exponent expressions with a division sign between. Now in algebra, that division sign makes it look like a fraction. So I don't want you to freak out because a fraction, it's a whole lot easier than it looks. What the quotient rule says is that if the base numbers, which is the bigger number, if they are the same, then you can simply subtract the exponents and keep the same base number. Okay? So we're going to take the base number of an m. We don't know what m stands for, but it's just going to be our base. And then we're always going to subtract top exponent minus the bottom exponent. Okay? 5 minus 3 is 2. And m squared is already as simplified as it can get. And so that's our final answer. Okay? Take a look at this problem. The exponents are a little larger, but we can still go through and use the same steps that we did this last one. The base numbers are the same, which is great. I'm just going to draw a little arrow here and just to show you that the base number x is going to stay the same. We're going to do top minus bottom. So 27 take away 16 is 11. And x to the 11th power, that's as simplified as it can get. And so that's your final answer. Okay, let's take a look at these two more examples to work through. Okay, so we were talking about the quotient rule. Quotient rule says you have to have the same base numbers. So we have an m again. So we have m. This time we have a negative 8 take away 2. So I still want you to do top minus bottom. Just because it's a negative 8, I don't want you to switch it around and say 2 minus 8, because that would give you the incorrect answer. So continue to do negative 8 take away 2, which is negative 11. Now the other problems, we were already at our final answer. However, m to the negative 11th power, this is not in proper format for exponents. We can't leave a negative exponent. So we're going to have to go through our rules of changing that negative to a positive. So it would be 1 over m to the 11th power. Now if you don't quite know how I did that, there's a whole video where I just talk about the negative exponents, so check that out. Okay, come down here. The reason I wanted to show you this one is because the y's are the same. We have our same base numbers, but then we have the coefficients 2 and 6. Notice that they're different base numbers. The 2 is different from the 6, and they don't have an exponent present. We have a visible 1, I guess. So we're going to work this problem slightly different. You can draw your fraction bar. The first part, y to the 9th, and then y minus, or y to the 4th, we're still going to subtract it. And that answer, it actually stays in the numerator. Okay, the ones previous, if you take a look back at this other one, the m to the negative 11th power, it was technically in the numerator. The denominator was not there. It was a 1, so I didn't write it. But it's always going to be your top exponent, take away your bottom exponent, and write the answer in the numerator. Okay. Then you have the 2 over 6. This is going to simplify just like any other fraction that you've had to work out. So the 2 and the 6 simplify to 1 and a 3. Now you can keep that 1 there in front of the y to the 5th power, or you can just say y to the 5th power over 3. Okay. So now I want you to pause this video, and I have some problems that I want you to try on your own.